guys. We have two presentations here, Matt and myself. Matt's going to be talking about building a Chrome extension, kind of leading us through a demo for a Chrome extension we built recently. And then I'm going to walk through some of our experiences experimenting with the Monorepo, mainly for our front-end code with mobile. Afterwards, just leave questions at the end. Feel free to ask questions. Feel free to eat all the pizza, pick up beer. Thanks for coming.
All right. So, hi everyone. My name is Matt. I'm a software engineer here at Exo Group. And about a month ago, I made my first Chrome extension, and it was actually pretty easy to do. So right now I'm talking to you by no means as a Chrome extension expert, but that's kind of the point I want to make to y'all. So it's not a hard thing to do. If you know a little bit of JavaScript, CSS, HTML, you can definitely build a Chrome extension too. Okay. So first off, just wanted to start off with the official Chrome definition of what an extension is. Extensions are small software programs that customize the browsing experience. They enable users to tailor Chrome functionality and behavior to individual needs or preferences. They're built on web technologies such as HTML, JavaScript, and CSS. So if you've ever found yourself wishing you could change something about the browser or the UI on a specific website, then it might be worth making a Chrome extension to fix it. Basic Chrome extensions are really easy to implement, so you don't need to have an amazing idea or something that's going to be super marketable. I think you mostly just need something that you think would be funny, something that you think would solve some annoyance that you've encountered before. And I'm sure you already all use browser extensions. There are tons of cool ones, and they vary a lot in how complex they are. For example, we have Chrome extensions that'll give you like the hex color for anything you click on in a website. You have ad blockers, you have password managers. There are simple Chrome extensions that just make like the new tab look prettier. There are also silly ones that are simple. One of my friends, actually this kind of, my Chrome extension is much more boring, but one of my friends kind of inspired me to look into it because she wanted to build a Chrome extension to play motivational DJ Khaled quotes when you open a pull request or merge a pull request, you know, another one. Haven't stolen that idea yet, but I might. So first, I want to start off just by showing you what I ended up building. And before I do, I want to tell you kind of the problem we had and what my desire was to fix that. So the problem is that we, let me exit out of this for a second. We store logs in this thing called Kibana. Mr. DevOps here is familiar with it. We use the Elk stack for logging. This is just some QA logs. And one thing that we don't do, though, is when we have JSON, or JavaScript objects, we don't store those as JSON type in Kibana because it takes up more storage and we wouldn't be able to have logs for as long without paying more money for it. But what I have done and seen like other engineers on my team do time and time again is copy and paste usually a bigger blob of JSON than this, pop it into a website like this, and then do that to make it more readable. So I was sitting back and thinking, like, how many hours of my life have I spent doing that? And I thought that it might be worth making something to fix this issue that's even, that's not only like doesn't cost us any extra money, but actually gets us additional functionality. So I created this Kibana prettifier. The HTML and CSS isn't super sexy here, but if you do that, it'll format your JSON. It'll do it for all of these guys. If I turn it off, it'll undo it so it can toggle between it. It'll also store the state. So if I refresh the page, Kibana's slow sometimes, then it's remembered that I have the prettifier enabled. So later on, I'll show you a little bit of the code, but first I want to talk about some of the like core components to a Chrome extension. So you have the manifest, which is the only required part of a Chrome extension, background scripts, content scripts, pop-up, and override pages. Now the manifest.json kind of serves two purposes. The first is it just has the basic information about Chrome extension. At the top here, we have the manifest version, which is kind of saying what version of their syntax are we using. Excuse me. Then we have the name, the version, and I think that might actually be, excuse me, all that's required. I drank too much beer before I started this. That might be literally all that's required to have an incredibly boring Chrome extension. I think you could like upload that and it would show a little icon for your Chrome extension. You haven't actually added an icon at this point, so it would just have the letter K, the first name of your Chrome extension. So to get any kind of interesting functionality, you'll also need to include some combination of background and content scripts and pop-up and override files, and those are all bound together here. As I'll talk about a little bit more later, there are no like require statements or import statements in a Chrome extension, so like this is what's gluing all of your code together. Background scripts run in response to some Chrome browser events. So these can include like installing an extension, adding or deleting a bookmark, typing into the Omnibox, which I learned is like the cool Google word for the address bar, and so on. So what we have on the right is just like a pretty simple background script I use for Kibana Prettyfire. And this is like boilerplate that you'll probably see in a lot of Chrome extensions. What it's saying is that when the extension is installed, add this rule so that anytime the page changes and it changes to a web page that matches the desired URL, in this case it's including a chunk of Kibana, then show page action. In this case, the page action is to show that the Kibana icon is accessible. So just quickly, like you'll notice that here, this is grayed out and I can't really do anything with it that's useful. But when I'm on, oops, 1 second, the Zoom just blocked me there. Okay. Here it's, you can see that it has a color to it and it's interactive. That's all that's doing. And they can also be configured to listen for a message that's sent by a content script, and that may lead you to ask, what's a content script? Well, here's a content script. Content scripts are files that run in the context of web pages. By using the standard DOM, they are able to read details of the web pages the browser visits, make changes to them, and pass information to their parent extension. So on the right, just to kind of remind you what the scope we're talking about is, I just opened the inspector. Everything that's your HTML, the DOM of the web page, that is like what your content script has access to. We're talking in contrast to background scripts, which are aware of like your bookmarks and the things you've typed into the address bar. Content scripts can be JavaScript or CSS. So you can imagine that maybe you want to have a JS file that selects all the image tags in the HTML and replaces the source attribute with like a picture of a kitten or something. Or you could, maybe you want to heavily restyle a page. So for that, you want to upload a whole CSS file. Little fun fact is that for security reasons and to avoid variable collision, the web page's JavaScript and the Chrome extension's JavaScript run in what Google calls isolated worlds. So they share access to the same DOM, but the JavaScript runs in different contexts. So you could have variables that are named the same thing and they're not going to collide. You can't access stuff that you shouldn't be able to access. There are a couple different ways you can run content scripts. There's the declarative approach, which is kind of what I prefer. I showed you a manifest.json earlier, and then just a little slice out of it, where we're saying here, so we can include the URL for the URL it needs to match, so it'll only run, the content script will only run on that web page. And we can have an array of JavaScript files. We can also have an array of CSS files if we want. And then we specify at what time we want it to run. And you have three options: document.start, document.end, and document.idle. And these are just kind of those hooks for how loaded the DOM is. And it's recommended that you do it at document.idle so that you're not blocking the web page from loading, because it has to run your content script first. Also, just it's easier for you because it's more likely that the DOM is fully loaded by the time that you are trying to run your script and potentially access the DOM. Also, you can inject programmatically using this like chrome.tabs.execute script. But I didn't really find a need for that, but it is a thing you can do. Pop-ups, finally we have a straightforward one. A pop-up is the thing that pops up when you click on the icon. And it's just a HTML file that you can use with CSS or JavaScript. You can kind of think of it like a static HTML page that opens fresh every time the user clicks on the Chrome extension icon. So if you want to accept any kind of user input in here, then you can, like with your JavaScript, you could add like an input field, an input element, and wire up your JavaScript to listen for on keystroke or a button for on click or whatever, and do whatever you need to do in the context of your Chrome extension with that input. Override pages. I actually didn't use one of these for mine, but they're pretty straightforward. It lets you override one of Chrome's default pages. I think there's only the 3: new tab, history, or bookmark manager with your own HTML. So if you have an idea of how you can do one of those better than Chrome does, then you can, if you want to see a picture of your dog or something, when you clicked open a new tab, then you can create an override page. All right, so those are all the main components. I know I just dumped a bunch on you. And so before I go demo stuff, I want to just tell you about some gotchas, some stuff that I learned the hard way and kind of drove me crazy. So scope in Chrome extensions is really weird. The JavaScript in your content scripts, background scripts, and pop-up scripts all run in their own separate bubbles. So to have them communicate with each other, you need to there's an API with Chrome to send a message and to listen for a message. So you could send a message from, we have the example of like my toggle in the Kibana Prettyfire. We know that the content script needs to do something when that toggle changes state. So we send a message from the pop-up JS to where the content script is, and it's listening. I can show you that later. No matter how you execute it or how many files you have your content scripts broken out into, they all run in the same context. Like separating them into different files is really just something that you're doing because you feel like it. If you have, so for example, if you declare a constant that has the same name in 2 different files that are both content scripts, it's gonna blow up at you. If you really need your own scope, you can always use Rapid in a self-invoking function. Oops. There are no require and import statements. You can't use them. So instead, with content scripts, take advantage of the fact that you can like run them all in the same scope. And in the manifest, you can put a bunch of stuff into an array of JavaScript files. You also can't directly use NPM packages, like at least not easily. You'd have to like minify them into a single file. I don't know of an easy way to do it. The one kind of fun fact is that I think you can, inside of your content scripts in the manifest, you can include a URL to fetch some minified library. So if you wanted to fetch jQuery or something, you could pull that in as a content script with a URL. Debugging is weird. So like I said, the pop-up, background scripts, and content scripts all run in their totally unique context. So you actually have 3 different inspectors you have to open if you want to debug it. So the content scripts run in the regular default inspector, but you have to open the pop-up debugger, you have to right-click on the icon and say inspect pop-up. And from like the Chrome // extensions website, they'll show you in a second. you can inspect your background scripts. Don't know how many times I was like, it's just a console log. Why isn't it firing? I don't see it. And it was because I wasn't looking in the right inspector. Also, every time you make a change in your code and you want it to be like locally and you want to have it update in Chrome, you have to hit this little reload button that has in that extensions URL. All right, that's everything. So now I want to kind of demo what I made for you. And so now you have all the concepts. Let's see if we can put it all together. I'm sharing my browser. Oh, I might need to change in Zoom. New share. Sorry, this might get tedious switching back and forth between contexts here. So here we have my manifest.json. Can I make this bigger? Is it somewhat readable to you? I'm embarrassed to say I'm not sure I know the zoom in hotkey. Was it? Command plus or up plus? It's not working. I might have used WebStorm. Zoom? Well, that's the different Zoom. Sorry, I'm gonna spend like one more second trying to figure this out, and I might do it. That's a little better. All right. So I think just to kind of demonstrate what the different parts of this do, I am going to try just kind of removing some stuff and showing you what goes on when I reload it. You know, in Zoom, is there a way to just like share share the entire window without having to like switch between the browser? Portion of screen. I don't know. All right. Well, I'll just I can switch back and forth a little bit. So I just removed a whole lot of stuff from my manifest.json, including like the icons. I should be able to reload this. You see the icon is gone. Now it doesn't have any content script. It doesn't have anything that it does, but we actually have like a Chrome extension that we could load, and it's in the browser. You see that it's been replaced with just the K for Kibana Prefire. Now if I flip back, this is going to be a little more actually, will this one? Ooh, nice. All right, there we go. So I'm gonna throw some, just kind of show you the debugging stuff. Show you if I just put a console log in each of these places, where it logs. So the background script you already saw. That's what makes that that icon interactable. The pop-up in our manifest.json, we just referenced the HTML with this page action here. And that just tells it that when you click on that icon, the pop-up should open up. The HTML is referencing a style sheet with some CSS that I kind of just stole because I hate writing my own CSS. And then and pop-up.js, it grabs the element here that's the toggle, and we add an event listener to when that checkbox gets clicked, And so when it's clicked, we toggle the prettifier, and that sets a key in local storage. And we actually send a message. This is what I was talking about earlier. We query all the active tabs in the current window. So it's just going to be the first one of those. There's only one active tab here. And we send a message to it. And the payload of that message is just saying should prettify is set to prettifier enabled. Prettifier enabled is just whether or not that checkbox is checked. And in our content script, we have a listener for that on message. It picks up the message from the pop-up. It looks at the should prettify Boolean, and just you don't have to worry too much about the actual like JavaScript logic in here because it's just JavaScript, but it knows whether to I've kind of tagged the divs that have JSON in them and what their current state is when they load up, whether they're prettified or minified, and it just kind of flips it. So that's pretty much all it is. If you look at combine all the lines of JavaScript together, it's like 100 lines of JavaScript maybe, and it was only like a couple hours worth of like writing code. So let me. Yep, added everything back into the manifest. Let's reload it. So inspect views, we got the background page here. I misspelled background, but you see that's already running because the Chrome extension has been installed. We're in the browser. And then pop-up. Inspect pop-up in pop-up. And then inside of here, there's a bunch of, maybe I should move this. There's a bunch of Kibana noise. But if we refresh this, we should see in content. So I think with all of that stuff, you should basically have the tools you need to make a Chrome extension. Like I said, if you kind of understand where each of what the role of the background script, the content script, and the pop-up is, like the rest of it is just basic JavaScript, HTML, and like CSS. So that part shouldn't be hard. At the end here, I just wanted to say thanks, and I linked some resources. Honestly, you can get a long way just looking at Google's documentation for Chrome extensions. They have like a little tutorial example one that you can build. There's a really great, I'd never heard of this guy before, but this guy who has Code Train is his channel on YouTube, has a really good playlist on extensions, and he's kind of figuring it out at the same time as you are. He like ran into a lot of the same weird stuff as I did. I linked the GitHub repo. This is public. I put a bunch of comments all over the place. One thing I forgot to say is like, you'll notice this has like a package JSON and a make file. All of this is really kind of overkill. I just have, the only thing in my package JSON is ESLint for linting purposes. The make file just has like npm install, runs the linter, and then zips it up for if I actually want to upload it to the Chrome store. But yeah, really the only critical files in here are manifest.json, popup.js, content.js, and like background.js. So yeah, that's about the size of it. It's also, I know it's a super niche app, but I do have it up on the Google Chrome store if you're curious.
It's all niche until you have one that's every one JSON object I see. And suddenly it's super useful.
Yeah. So that's it. Do you have any questions?
So,
Yeah, go.
When do you think you should use an extension instead of, say, something like tamper monkey script? Certainly simpler, but may not have time to function.
To be honest, I'm not actually familiar with a tamper monkey script.
What you're doing here with the background stuff and the pop-up isn't available with tamper monkey, but you want to manipulate the DOM and tamper up your response, basically does that.
Okay.
Most of it's designed to, I'm sure there's some way around making the DOM reliable, but the basic answer is that basically when it's the page to load, and it does manipulations in this. I usually do random stuff with our websites and basically fill in forms for me. So automatically I use it to make, fill in stuff for Steam. I want to redeem all my keys and so forth. I use it for that. From what I've seen at least, the functionalities that are listed here, there is no way you're going to be able to easily use tamper-monkey a pop-up or anything that lets you configure the extension. It's all going to be either in the script or on part of a page which may conflict with whatever the author made versus you.
Okay.
I didn't know if you had any other consideration. It's basically, it's sort of just a kind of a JavaScript that runs against the page when it's done.
Okay, that makes sense. So like the only thing it's missing there is like you couldn't necessarily like toggle on and off or like, I mean, there's lots of Chrome extensions where there's like a user input, like you're typing in a word or something if you want to get a definition for anything like that. I think that's the difference is when you want it to be a little more interactive, but that seems like it would work as well.
Sure, and it looks like also your background process. So that tamper-monkey likes to run once and done. That's not it. It's not simple.
Oh yeah.
Some of that's just a consideration of how much edge space we take up the browser. It's reasonably large to do, but it's not needed for the browser necessarily.
Yeah, yeah. It is nice that you can scope a Chrome extension, so it's not really costing you any resources if it's if it's not matching the URL for the page you want it to run on, or it's also nice, I think, that you can store like some setting in local storage, and then like it'll just remember the state.
You can store it in Chrome, and you store it in local storage. You can also store it against the user's Chrome profile.
Probably.
It should. Also, if I understand correctly about extension, you work with Chrome.
Mm-hmm.
You know, whenever you sign into Chrome with your Google account, it pulls all your extensions with their settings. So that's the other benefit I've seen is that this is easily portable to whatever else I'm using, whether it's a computer, whether it's something like a hotel or on my phone. I can pull that extension much more easily than trying to feed into the script. And honestly, yeah, it's kludgy, but the point is that it's there for most testing purposes and probably to start building one of these. This is kind of a finished product.
Yeah.
So it's really nice to see something with a little more capability and availability to transform what I've been doing already to just manipulate it down to something that I can also hand out to other people.
Yeah.
That's the main thing I see from this.
Yeah, that sounds
You
good.
have to know what you're doing. You have to then something like tamper a script, even though it's very understandable with JS, and you don't, and you're like, well, how do I apply this or what I do? I see many extensions.
Yeah, I think one thing to remember, like I didn't actually dig into it too much, but mine has pretty limited permissions. It just says local storage, declarative content, which lets me do that background script, and the active tab. I'm not even actually sure. I guess I probably do need active tab, and then just this URL. If you're trying to get into like the actual like users settings that are stored in Chrome, like tied to their account, you might have to add some additional permissions, and just makes it so that when the person downloads it in the Chrome store, they're notified that they're giving the Chrome extension all this access.
Yeah. You can see a lot more of that, right? That's required. It has to be allowed for people to see stuff.
Do you have a question?
Yeah, so I know this is kind of like a one-off project for you, but if you were to support with the feature device, where maybe you are finding more like
I haven't thought about it a ton. A coworker, Edwin, was actually telling me like, oh, why didn't you add this? And I can't remember what it was now. It was something to like kind of enhance the Chrome, like again, an enhancement to Kibana, but kind of a different idea. I think it was like maybe if you had like an ID or something and I wanted to pop that into the search bar, or do something just to make like querying in Kibana a little bit easier. I think there's opportunities to play around with that, but it'd be kind of fulfilling like a different purpose. So I don't know. I kind of want to keep it like a super narrowly scoped Chrome extension instead of making it too complicated.
Having the stuff before.
Yeah.
I don't know how much you're going to use it outside and once you manage to bring fire. Certainly, there's something to be said for being able to put with that. It's pretty got it.
Yeah. Cool. Any other questions? Awesome. Thanks, guys. Close out my stuff. It's all yours.
Thanks. So what's up, guys? I'm John. I'm a senior manager here at XO. And so recently, we've been diving into the world of kind of shoring up our front-end architecture, and we've taken a couple of different routes there. And so I kind of want to walk you through that journey and just some of the things that we've learned along the way and some of the benefits that we've kind of reaped from doing it this way, and some of the future state that we'd like to get into and how it can kind of eventually save you time, make your development process more efficient, improve developer ergonomics, and all those kinds of things. So a little bit first about XO Group. As I told some of you before the meetup started, we're a life stages company. We make applications that serve some of life's most important moments. And for today specifically, I'm going to be talking about the Knot, which is the application that we mostly work on here in Austin. And a little bit about the Knot, just to kind of get an understanding of where we were coming from. The Knot is the leader in the wedding industry. We have about 750 employees worldwide, 250 in the engineering department alone, about 25 to 30 squads in 5 offices, 4 time zones, and 2 continents. And so pound for pound, we do everything from weddings, from planning to organizing to managing the vendor side of things. The company as a whole is just very distributed, and so that comes with its own challenges, especially if we're organizing your code and managing code from multiple teams in multiple places. I specifically work in the local zone of the Knot, which serves a 2-sided marketplace between 2 different types of users, which are couples and vendors. So I'm going to be focusing on that subset of engineering for now, just because that's kind of the starting ground for where we're testing some of these ideas out. So what are some of the problems that we actually had? There's different time zones, like I mentioned, standards, technologies, and tools across the company. We want to, some part of the company are using older Angular apps that just have been around for a while. I think there was some Backbone or Ember for a while in some parts of the company. We've been using React very heavily. Another thing with time zones is there's a 12-hour difference between our China office and our office, and so that causes a little bit of just disconnect, and it's hard to have the best communication there. Same thing with state containers. There's a little bit of a difference there. There's horizontal product ownership across a lot of the company, and that means that there's like a web team for a specific subset of functionality, and then there's just a mobile team, and it's all mobile. And so that's can create a lot of friction. Not only is it a lot of ownership or some things, but a lot of friction for feature parity between those things, because one team has time to do it, one team doesn't. And another part of that is there's legacy front-end technology. Some of the things that I had mentioned before, until recently, there's actually a good portion of .NET code floating around, which was eventually retired. But still some Angular floating around there. And then there's inconsistent architectural paradigms for front-end and back-end. And although that's not really that big of a deal, but we're very modular on the back end, and then we have these large monoliths on the front end. So it can just get a little bit confusing. And also it's hard to reuse code. Obviously, like, we want everything to be modular. We want to do something once, not do things multiple times. So that's a big deal. So the goals in trying to rework our front-end architecture while we had this opportunity were to minimize redundancy and maximize modularity, increase flexibility, efficiency, and developer ergonomics, and support product verticals across multiple platforms. Instead of having those horizontals, someone just has feature A and they have it on every platform. Part of that is actually thankfully on the vendor side, we have React Native, which kind of like helps us along there. So it's easier for an engineer to be fluent in multiple platforms like that. Last, we wanted to support multiple squads inside of a single application. For example, like the vendor-facing web app has too much functionality for one team, so we just don't want to step on each other's toes. The very first try that we had on this left-hand side, we were in the middle of an 18-month migration from some legacy .NET to Angular single-page application and Node. And the vendor app was split between two domains, which you can see there, the notpro.com and partners.thenot.com, which is the .NET stuff. Just because there were some inconsistencies when they were actually migrating, and so it was a very messy migration. The new world consisted of, on the right-hand side, introducing a proxy layer, and that just had the networking level just to be able to route traffic all under the same domain, make things a little cleaner. And we were also able then to spin up these siloed React applications next to this larger single-page Angular application, which made migration much easier. So imagine if you have something that has, let's say, 12 different features that are fairly large and can stand alone as their own app. That's going to be, it took 18 months to do it from .NET to Angular. If we ever want to do this again, we don't want to have just some jumbled app where we have to do everything at once. Having siloed applications like that and having the modularity on the front end means that we can strip things out, use the proxy to just flip a switch, and then we have our new app flowing through. The new React apps, we spun up like a scaffold. We use a lot of shared resources. We set up like a shared SDKs. There's a shared UI library that we utilize. A couple of other things, some reducers that were shared between the React apps. Made it really easy to get the new apps off the ground and up and running. You know, the boilerplate there, just give 50% of the app running already. And then the traffic was just routed to the Angular single page application. It was just unimpeded and it flowed through the app routing as usual. So it's kind of a seamless transition. The only thing the user's really losing is just that flicker whenever it reloads. There are still some issues with doing that on the web. So there's issues with multiple repositories. Mostly there's developer friction. So if it's not easy to use, people won't do it. So if it's not easy to make shared resources, your developers and engineers won't do it. Multiple repos can lead to repetition and with configurations, project setups, unless you're putting in a lot of work ahead of time. That can get kind of tiresome, difficult to maintain. In certain cases, obviously, maintenance and dependency upgrades can be cumbersome. Publishing things, you might need to do things in a certain order because of interdependent dependencies, things like that, and having to go do that in multiple places. Discoverability is a big problem. If there's something that is reusable, but you can't find it, it's pretty much useless. And then onboarding, which really hits home for me. Hard to acquaint new engineers with a very distributed system. It just takes more time, and so you lose productivity. So because of these issues, we decided to go with a monorepo. And a lot of people just think that a monorepo is like a monolithic application, but there's obviously some key differences here. There's some guidelines. The monorepo is just a single code base made of independent packages, and the independent package is the most important part of that. Modularity is a first-class citizen. The packages can be developed, published, tested, deployed independently of each other, and easy for multiple teams to manage their own product inside of a single application. So it's more than just products organized into subfolders, because these have the ability to function autonomously on their own. They really shouldn't even know about each other. By ensuring modularity as a first-class citizen, we kind of avoid those pitfalls of jumping into spaghetti code, which can kind of big problem with monoliths. So each of those packages has to have that clear defined boundary and ownership. With a monolith, you have like single code base, normally interwoven code. It's difficult to avoid these kind of conflicts. You have to test and deploy the entire application at once. It's difficult to refactor because it's hard to rip pieces out. So essentially our second try was the monorepo. The squad product verticals, or the apps, separated into individual packages. The project has a root level package file with shared dependencies and global configurations, and then the individual apps all have their own package files as well, so they function as just standalone single page applications. There's shared components and resources within an arm's reach. So over here we have the bundler that we're actually using now looks for this packages folder. in there, you can set up the configuration to look into whatever folders you want. So this isn't really actually particularly how we have it organized. It's just a nice way to show you the difference between them. So we have a shared folder which has an analytics package and a UI package. Each one has its own package file and its own dependencies. It can be deployed independently. And then there's a subfolder for apps. And let's say we have multiple apps in there. They may have different dependencies depending on what those apps are doing. At the root, there's another package file, which is just those global configurations. So there's a couple of tools here. The Monorepo build system and the dependency management tools. The Lerna allows you to share the packages that live in your Monorepo with other apps, kind of like NPM packages. Make sure that the versions between interdependent packages within your repository are kept in sync, and then it also allows you to publish your packages to NPM if you wish to have them versioned. So it allows a lot of flexibility there where you can just have these most recent across the board, or if you have certain things you want to version, you can do piecemeal upgrades then. Kind of allows you the same flexibility you have with multiple repositories, but you have everything in one place. Alternative options, those are like Bazel, which I think is Google's, Buck, which is Facebook's, Pants, which is Twitter, I think. Yarn has Workspaces, which is kind of similar. So pros and cons of doing it this way. The pro, a comprehensive pull request. The PR can have changes to all your packages and files all in one fell swoop, instead of having to say, hey, here's the change to the SDK, and I'm another engineer and I don't have any context to why you're changing the SDK. Instead, I can see, here's my SDK change, and then here's my implementation on the mobile app or in web. And also here's a change to some shared UI components that this affects as well. It's also easy to see recent changes and commits to shared dependencies. So this extensive commit history, if you're ever wondering why, like, hey, the SDK is working yesterday, you don't have to go to some other repo. It's all right there for you. The modular design ensures clear boundaries of ownership. So the separation of concerns there, it kind of helps avoid stepping on each other's toes. Once you have a more mature set of shared resources and UI components, then you kind of don't have to worry about that as much. The developer ergonomics, which is obviously really important. It's easier for people to get around. It's easier to onboard. Less context switching, which is also really important. You don't need to readjust when you're going to another code base. There's flexibility there for migrations, refactors, different tooling if you want it. There's some level of autonomy available in the decisions you make. Atomicity, if you want. If you really wanted to change things across the board, you have the option to, or if you don't want that to happen, you can version your packages and publish them out. Less configuration up front, and easier to control the coding aesthetics. You can define linting and coding standards in the root of all the apps so that you have multiple teams that are all kind of following the same guidelines. Some cons that we've found, which are really just kind of take them for what they are, but branching strategy and process changes. Obviously, if you have multiple teams working inside of a single code base, branching all of a sudden becomes much, much more important than just a close-knit group of 4 to 5 engineers. You need to have a really defined strategy there so that you don't run into as many conflicts and you're making sure everyone has the most recent changes at all times. Very large code base. For most use cases, this probably isn't really a big issue. Most people will have it, where you're gonna have to clone it down once and then you have it. But obviously, like that can be an issue with a lot of it. I think Google is in the terabytes with their monorepo that they have, and it's a few million lines of code, so it can always be worse, I guess. The need for additional tooling, which really, is just once you have it set up, it's really not that bad. Lerna is pretty encompassing for everything you need. There are some issues that we've had with React and React Native specifically with symlinks, and so there's a little bit of extra kind of work to get around some of those issues. Releases need to be coordinated. One thing is that, when you're all in one team, you kind of have a de facto gatekeeper. When you have multiple teams working inside of the same repo, there's not really necessarily a gatekeeper unless you define that ahead of time. And so you need to understand how release branches get cut, or when the cutoff is, or how that process all works before getting into some trouble there. So the future that we'd like to hit, originally we we considered attempting to merge the mobile and web monorepos into one, because we wanted to be able to have that cross-platform experience for our product vertical, where I can go change the SDK, change the UI components, change mobile, change web, all in one PR. And that was like the ideal world that we wanted to get to. There were some challenges, some unique challenges, specifically with like dependencies, CI/CD. Learn actually makes it possible for you to specify like .web versus .mobile on certain files. You can also specify .android, .ios for React Native, so that it actually knows, which file it's actually like preferred to use if there is one. So we had this idea of there will be like, agnostic components, or ones that have a web implementation, one that have a mobile implementation. Because of mainly like the deployments, we instead had a plan to create a core monorepo, which first kind of sounds counterintuitive against everything that I just said, but the core monorepo would have all of the shared business logic, but still utilize that web and mobile differentiation in there, so that both libraries can essentially consume the same piece, and it will just know in those packages which direction to go or which file to use. And in some cases, we may be able to use just a generic implementation for certain business logic, maybe for state and things like that. For some things, maybe we have a mobile and we have a web implementation. I think that I had heard someone once say, it's like, instead of saying, you have to code it twice or code it 3 times, it's coding it 1.5 times. Because you really just have to make it once, and then you have to go and kind of maybe make 1 or 2 kind of pseudo implementations there. And so, I mean, this is an ideal state. We're still learning things as we go, trying to document it as much as possible. But the ideal world is just trying to make this whole process more efficient and making our teams able to make changes on multiple platforms and move as quickly as possible. So anyways, I'll put these slides and maps online as well. So I don't mess with me on Twitter. I think I have 2 tweets like in the past like 6 years, but my email's there. But yeah, any questions? Sorry, I was the wrong beer. What was the question? For web, it's a little untested, but for web, it in theory should be a little bit easier for us whenever we get to that point. Right now, we only have 1 team working in the web monorepo just because of priorities at the moment. In mobile, what we've found is that this is where like branching becomes very important. Product normally dictates what a release is. And so they'll have the cutoff for, say these 3 features will make it into the next app release every 2 weeks. So 2 weeks from now, these 3 features we expect to be there. The 3 teams working on those 3 features have their own feature branches. And then when those features are complete, they're constantly pulling in development just to make sure it's up to date. Merge their features in as soon as they can do hot fixes directly on the development branch then. And then as soon as development's cleared by QA, we get to that 2-week mark. If your feature isn't done and you haven't cut it in, then it just doesn't make it. But let's say ideally all 3 teams make it in. Development gets cut into a release branch, and that release branch gets sent off to the App Store. It'll be something very similar for web, but we aren't beholden to like a cadence of releases as we are in the App Store. With web, you'll still have your feature branches, and you'll still, as long as you're making sure that you're current, and that's kind of a change in process for us, making sure that you're just always current in your feature branches to have these long-running branches going, and then merging those back in. We have continuous deployment in our web anyway, so as soon as you're ready for those changes, they just go up. Right now on mobile, obviously that's a little different. We have a buddy build for it's a system just for building our apps and doing a little bit of QA work. For web, we have Jenkins hooks into our branches themselves, and it takes the rest. Yeah.
So you mentioned making relative silos react adapts. Is that something that's difficult to do in Angular or not available?
I wouldn't say that. No, it's definitely possible to do in Angular, but
We did it for a bit because we have a China team and they wanted to basically the same thing. To modularize that so that they could build their own features and then install them in their main app. But this is way more elegant and it's not Angular.
yeah, it's not necessarily a slight against Angular either, just because I mean, we prefer React, but it was more just one of the reasons to go to React was just because I mentioned there is like a pattern library that we wanted to use as an in-house tool, but that was obviously we needed React to use that. And it's just kind of more of a front-end standard across the rest of the company, but we just kind of wanted to get everything.
I think we also have to focus on some which of these things as well, why the choices were made, make sure that line checked out.
Yeah, and for long term, I mean, it makes sense. If product wants us to own a vertical, then it makes sense for us to have someone who understands, React front and back, and they can automatically contribute to mobile right away. So.
Right, yeah, that seems to be the big benefit. Very components, small modular, particularly, yes, it's try very hard, very similar, not exact same for web and mobile.
Cool. Any other questions?
What is that?
This is actually the microphone,
Oh, okay.
but it's like a fluffy box, so you can like throw it. What is it called, a bump box or something?
It's basically just a Bluetooth speaker pad, and we did like they're very helpful. You have like a 200 people, you know, like over somebody without having someone run across the aisle.
You can imagine.
Oh, the whole thing.
You can imagine chunking a regular microphone at someone's head. Cool. All right. Well, thank you guys.